Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface and how powerful it is. And in order to continue our discussion, I'm going to basically look at three important topics. One is, can we overload a native method? And the answer is yes, we can. And because JNI uses fully qualified name for C++ methods, and if I go back and refresh your memory, the naming convention is Java underscore, this is always there, and then package hierarchy, package 1 underscore package 2 etc underscore class name underscore method name. All right, so this was basically the JNI method in C++. All right, but then if we have overloading methods, if two native methods are overloading each other, and they have to have basically unique signatures, right, in C++. So how does the JNI create a unique signature for these two native methods that overload each other? And the answer is JNI uses exactly the same convention, Java underscore package name underscore class name underscore method name. But in order to specify the overloading feature, it uses underscore underscore, two underscores, all right, and then the method parameter signature. So because when two methods overload each other, their package name, class name, and method name is exactly the same. The only thing that is different is the signature of the parameters that are passed to the method. So the return types are also identical. In fact, if you have two methods that have the same package name, class name, and method name, Java compiler doesn't allow you to have two identical methods with only different return types. So that's not basically a valid overloading, right? Overloading means the signature of the method is exactly the same, the return types is exactly the same, but the signature of the parameters or the method parameters are different. So here, for example, this I have a overload native class that has two native methods that have exactly the same signature. So the method name is the same, return type is the same, both of them are native, both of them are static and public. I mean, they don't need to have the same access modifier, so one of them could be public or private, doesn't matter. But they both are static and native, double function, so the name is the same, but the method signature is different, or method parameters is different. So this is a valid overloading, okay? And then if you see what happens in the JNI, JNI creates the JDouble return type, Java underscore package name underscore, basically the package for this class is test.overloading. So test underscore overloading underscore class name underscore func method name. But this one has one double parameter, so underscore underscore d, and this has two double parameters, so this one becomes underscore underscore dd. All right, so this is exactly the method signature in this comment that JNI creates. So JNI differentiates the native methods that basically overload each other by appending the underscore underscore method signature or method parameter signature. This is the signature of the parameters, one double or two double, to the basically to the C++ codes. All right, so let's head to Eclipse and try to examine this in more details. So if I go to Eclipse, I have created an empty Java project, and in this Java project I'm going to create a class, and I'm going to put it in a package called test, and let's call this test native or test native test overloading. Let's call it test overloading. All right, and okay, so it creates the package here, and then I put it creates the Java file, the class file, and here all I want is to have a public static native double func and double x, and public static native double func double x and double y. Now obviously I can continue and have, for example, I don't know, public static native double func double x and string text. All right. So this is the first step in doing mixed development. Create the Java file, add the native methods, and here we are looking at the valid overloading of native methods. Now obviously we can have a regular method and they can still overload. They can still do a valid overload of native methods. So public static native double, I mean let's for simplicity remove the static for now so that we can instantiate the class and use this method. And then func, and let's say double x double y and double z. Okay, so Java compiler happily allows us to, okay, this one shouldn't be native. So this is a regular Java file, and this is a non-native. So this is a regular method, right? And the class is not abstract, so this is not abstract. So we should provide a body. So let's say we just return x plus, let's just return x. All right. So Java compiler happily allows us to overload a native method with a non-native, a regular one, but obviously this is a regular method, so we have to provide a body. Where do we provide the body or the implementation for a native method? It's in the C++ code. So this was step 1. So I'm going to mark it with step 1 of doing mixed development. Step 2 is to create a C++ project. So I'm going to C++ basically perspective in Eclipse, and I'm going to right click new C++ project, and I'm going to create a hello world project. Let's call it native underscore C, the toolchain macOS GCC, and doesn't matter. Okay, and next let's just have both debug and release. This is doesn't matter, and then finish. All right, so right now I'm in a specific working set. So in order to bring that project to my working set, I clicked on this arrow here, this downward arrow, and select edit active working set. And in the active working set, the project that I just created is native C. So I'm going to add it to my working set. This is just to have a nicer, basically a cleaner workspace. I have many projects in my workspace, but at any given time, I just only work on like 1 or 2. So it's better to create these working sets, and you can select how to represent the project in a working set. Top level elements are projects, and project presentation is flat, for example, or hierarchical. And you can configure the working set differently in the C perspective than in Java. All right. So I'm going to create a new folder, also a source folder called header. All right. So we have a source folder for header and a source folder for CPP. And this native C is just a hello world. And obviously I can build it in the debug mode. And then it creates the binary, the executable file, and then run. And the hello world. So our C project is set up nicely. All right. And then step 2 in our mixed development is to go and create our external tool, which I have created here. So we discussed about Java Edge using -JNI and pointing it to the bin directory of the project, or Java C -Edge, and we pointed to the basically the Java file, not the class file. All right. So Java Edge, and what I'm going to do, I'm going to basically point it to this header directory in my C++ project. So I want to create the header files and put them directly in this header folder. So -D is a parameter for Java Edge, which tells the Java Edge where to put the header files. And then I'm going to basically use the workspace parameter underscore colon, so colon native underscore C, which is the name of my C++ project, and then header, and hyphen JNI, and Java type name. This is the fully qualified class name, because Java H acts on a basically class file, not a Java file. All right, so this should work fine. So if I run it, I believe I should be able to get the header file for this class. Test overloading. And so step 2 is complete, right? Step 1, write your Java and use the native keyword. Step 2, create your C++ project. Step 3, configure your external tool so that you can create the header file. Now we have to go back to our C project. Obviously, we don't want to create an executable, right? We want to create a dynamic library and then load it in the Java code. So the first step here is that if we go to this include, we said in the previous lectures, we said that we have to tell the C++ project that include the JDK files. So right click and go to properties, and in the properties, C++ build settings. And in the settings, let's set the GCC C++ compiler dialect to C++. The standard is C++11. That's the standard that I use typically. And then we go to the includes. And in the includes, we click on the include paths. Click on add file system, and JDK 8 I'm using, and home. In the home, we have this include. Let's open it. So this adds the JNI.h, but then we have to also add the machine dependent header files, which is in the Darwin or Linux or Win, whatever your platform is. So JNI MD, okay, machine dependent. Now we're good. So all these errors should go away now. You can successfully find the JNI.h. So our C++ project is configured. So, but the problem is that right now the project is set to create executable. We don't want to have an executable. We want to create a dynamic library. So whenever I build this in the debug mode or release mode, I want to be able to build a dynamic library. So we right click, go to the properties again, C++ build settings. Now we go to the build artifacts, and instead of executable, we set it to shared library, and it automatically adds the dilib as the artifact extension and the lib to the prefix of the library. Okay, and tool settings again in the linker. Right now we are not linking to any external C library. We will look at how to add external C libraries to our project. Shared library settings, it is selected, dynamic lib, so everything is selected. Apply, okay. So if I build this now, it will create a dynamic library. So as you can see, dilib, right? Okay. So what do we need? So obviously I don't need this main method. So what I need is to, first of all, I need to include this file, right? This header file. But remember, this header file is now in another folder. So I have to specify the relative path. How do we specify the relative path? We use the double quote dot. And if I hit control space, dot slash means basically go one level up. So dot is relative to this source folder, right? Because we are at the CPP, so it's the location at the CPP folder, which is source. Dot means go up. All right, then it goes to the native C folder, and now I should tell it go to the header file, so, to header folder. So header slash whatever that is there. All right. So if I zoom out, so this is how we specify relative path. We talked about the diamond notation, and we said that typically for the header files that are in the compiler includes path. This one, we just use the diamond notation. For example, iOS stream or JNI, for example, we just added JNI.h. all right? But remember, we don't need to add the JNI.h to our CPP, because when we include the header file, JNI.h is already included in the header file, so adding it to the .cpp is not necessary, all right? What else we do? We copy and paste these signatures, and then go back to our native basically CPP, all right? And then if I have many methods, basically what I do, I copy this JNI pointer and then click Command F, and then I say replace this with basically environment, and then replace all. So it automatically replace all of them. JObject refers to the current Java object, because these are not static methods, these are instance methods, all right? So if I copy this test overloading, which is my object name, and click on this JObject and press Command F, it opens the find dialog, and I say replace it with JObject Command V and replace all. So this is a convenient way. If you have many methods in this CPP file, we can just quickly. And JDouble, this one was X, and we want to return X, all right? And then this one was X and Y, and these are all overloaded, right? And you see how this works. The signature of the parameter here is a double, which is D. For the second one, the signature is DD. It takes two double parameters, and again, let's return X, the first one. The last one takes a double and a Java object, and Java objects are specified by L at the beginning, and then the path to the basically the object, and then semicolon. So this L and this semicolon is necessary. So this is a signature of a Java object. And again, we will look at this in more details when we talk about how to access the fields and objects in C++. If how to access the fields of a Java object in a C++ file. But for now, if you want to quickly know the signature of a parameter, of a Java parameter in C++, Eclipse has this very nice thing called the bytecode view. So if you go to Java perspective, show view bytecode, I have it open here, and if I click on this string, it tells me that it's the signature, basically the signature of this function is it takes let's click on this func. It takes a double D and then an L Java / lang string semicolon. Okay, so this is my double parameter, and L Java / lang string semicolon is the signature of a string parameter, and this function returns a D. All right, we will look at this in more details, but in general, the signature of a method is defined by a parenthesis, and then the list of the signature of the parameters of the function in parentheses, and then the return type outside the parentheses. All right. So back to our C perspective, C++. Now, as you can see, the last one, again, up to this point, which is the function, it's the same as the signature of a method, but then the method parameter signature is D, and then Java L Java _ lang _ string, but it cannot add semicolon. Remember, the signature of the object has a semicolon. It starts with L and ends with a semicolon, but C++ doesn't allow you to add a semicolon here, right? So it adds a 2 here. It's another thing that we don't really need to care about that, because JNI creates it. But if you want to write the method signature manually without using the JNI H or basically Java H or Java C, you have to be aware of this. So instead of semicolon, it adds the number 2 to it. Okay. And then we have JXX, JString text, and let's again return the first parameter, which is X, which is a JDouble. All right. So we configured our C project to create a dynamic library. So all we have to do, and we added the implementation for these overloaded methods. And we had one more method overloading, but it's not a native, it's a regular method, and it still returns it has to have a body, and we already provided the body, which is returns the first parameter. All right. So what we need to do now, we need to build it either in debug or release. So let's build it in a debug. Everything is finished. The build was successful and there was no problem. So the dynamic library is generated. What is the next step? I create a folder here and basically call it, let's say, JNI, and copy this native library to my JNI folder in this Java project. Let's go back to Java perspective, okay, and to my Java class. And then I tell Eclipse, so build path, configure build path. I tell Eclipse that we discussed this in more details in the previous lectures, that take this source folder in this project has a native library associated with it, and we just click edit workspace, it's in the JNI, and okay. Now the work is, so for the entire Java codes that are inside this source folder, the parameter -d java.library.path is set to this dynamic library. Set this to this folder. All right. Now that Java knows where the dynamic library is, we just tell it to load it into the memory. System.load library, and load library takes the relative path from the root, which is the project folder, and basically we specified the name of the library, and we mentioned that we dropped the lib from the beginning and the dylib extension from the end, so the name becomes native C. All right, so this is done. So if I run this, okay, let's add a main method to it, and let's create a test overloading instance, new test overloading. So if I run this at the moment, it runs file, but let's do a sysout on the func dot basically test dot func and $x 1.1, and this is the native method. All right, this one, let's run it. 1.1. all right, so this works fine. And then let's use the other overloading method, which was the native 1.1 2.2. so this is the second one, which is a native method. Let's run it. 1.1 1.1, and the third one is the string one, so $x hello. All right, this is also a native method. It has an n here, so if I zoom in the signature, there is an n here, which signifies this is a native method. And if I run it, it returns 1.1. Finally, we can use the non-native method func, which is again a valid overloading of these native. So test.func 1.1 2.2 3.3, and it returns 1.1. So as you can see, we were able to overload native methods with other native methods and also with regular non-native methods, and all of them worked fine. And the signature of different native methods that overload each other is basically __ the parameter signature. So here we had one parameter which was a double, so __ d. Here we had two parameters that were double, so __ dd. Here we had a double and a string, and so it's __ d l java /lang string. But we cannot have a semicolon, so instead it uses _2. Okay, so I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.